Okay, it looks like we are live. So welcome back. Today I'm going to be continuing to work on my virtual machine. Okay, so last time, uh, I had to end early and I wasn't able to finish what I was working on. But basically, I was trying to implement types so that we can know what the type of the whatever the element is on the stack. So we can take a look at that actually. That's the wrong one. In here, yeah, in the header file. Basically we define in here. These are the different data types of what it could be. And then here in the stack previously was just a stack of words, but now it's a stack of data types and words. It's a stack of data, which has a data type and a word. All right. Yeah. So that's basically what it is now. So each element could have a type associated with it. So I kind of got it working mostly. So if we look at push, here we push, and then we also push the data type, which is defined actually in the assembler where we can get it, because it's pretty easy to actually figure out. Let me just make test.tasm. There we go, and then I'll open it up here. So if we push 5, we know that that's an integer, so it's easy to identify that as being an integer. So then we can. The reason I wanted to do this is when we perform comparisons, I didn't want to have a different operation for comparisons of floats and integers and all that stuff. Yeah, so basically, what I was thinking was then we could do compare equal, right? So put 10 or whatever, compare equal, and then it'll take whatever's on the top of the stack, and we'll use that type to compare it. And then I think we're gonna have to add something where it can be like cast, or maybe like like 2f or something like that. Well, we have to, just italk, something like that, into float, or float to int, whatever. Where basically it takes the topmost element and it casts it. Yeah, and I think that would work. And then it actually changes the type. So then, like, if you wanted to do, yeah, if you wanted to do certain things, then you could do that. So I think that is something that we're gonna do. So right now, in the compare, right now we just interpret it as an int. What we need to do is check the type and the type of the topmost one. So that is going to be A. A is the topmost. So basically, yeah, so we need to check the type. And then depending on what it is, we want to do different things. So basically, if a.type equals int type, then we're going to do this and compare it as an integer. So let me just grab that. There we go. And then, yeah, so I'll clean this up afterward. And then else if a.type equals float type, then yeah, then we'll do the same thing. Oops, yeah. Except we'll interpret it as a float. As float, there we go. And then yeah, so what we're gonna push is always gonna be an int type because it's just 1 or 0. So yeah, I think that should work. So we're going to interpret it as a float. So if you have something that's not a float, and then on the top you have a float, it's going to interpret this as a float, and that could mess some things up because it's not actually being casted, so it's just kind of a nonsense value. I can kind of show that if I print. And then go ahead and compile this, and then if we do that and we run it, you can see as float, it's just 0. And if we do 5.0 like that, then this is the int representation. So we need some way to cast that. So that's sort of what I was talking about. So right now I'm not going to worry about that, but we can sort of check. We have a decent way of checking, because this makes the comparisons a bit better. So yeah, so we push it back as the same type, and then we interpret it. So yeah, so I think that should work now. So if we push 6.0, well, actually we'll make the same, and then we'll compare equal, and then yeah, we're just putting what's on top so we can see what it compares at. So 1, so they are equal. But if we do something like that, then it is not going to be equal. 0, yeah. Because that is how it is represented. So we have that. So what else can we do? Yeah, and then if we have 5 on top, actually I think that is the test I did before. And yeah, so none of these are going to be equal. However, there are some things that would be equal. So if we push a character, So like 0, for example, and then we push 48 as an integer, those I believe will be equal. Yes, because 48 is the ASCII value of character, and that's really all that characters are, is a value. So I can sort of show that if we print it. As character, it's 0. Oh shoot, actually, that's quite interesting. Yeah. So I'm not sure, actually, why that would be interpreted that way. But you can see this. Yeah, so I don't know. So I'm gonna need to check on that. Should we add an else if for this could obviously be abstracted away, but we'll do else if a.type equals char type, then we'll do it as characters. Yeah, so dot as char, even though this is ints essentially, but yeah, so, and we're still gonna push int type. Okay, so now should we check the pointer? So if the pointers are the same, that's probably a good idea. Equals pointer type. Then we'll do this thing right here. There we go, and as pointer. So that way we can compare all the different types, and then else we'll just get an error. Yeah. Error unknown type. Okay, so alright, so now so that should cover all the types that we have then. And this could probably be a switch statement rather than if else. So that's one way we can start cleaning up. So we can switch a.type, and then we'll add a case for int type. Right. Case for float type, and then a case for char type and pointer type. Type and break. Alright, and I forgot semicolons on those. Yeah, and then we can just, so this could probably be a macro. I think we can make a macro out of this, or yeah, that's probably a good idea. So yeah, so let me try to just do that. So define let's see, so compare, this could probably be for all of them. So compare type, compare as type. There we go. And then so we need to take, so we always are going to have a and b in dot word. So basically it's just the basically the type, that's the as, int, as, whatever. And I think that's all the information that we need, actually. So then if I take this, so I'm not very good at working with macros, so I'm going to try to figure this out. So I think we need a do like that, and then while 0 without the semicolon at the end. So a little something like that, and then we have to add, I think if we do something like this, and then we replace, let's see, maybe that won't work. Whoops, hang on, wait. Let me try that one more time. Yeah. So replace /n with just slash like that, and then /n. Whoops. Okay, so I guess that doesn't work. So I'll just kind of do it like this. Because you can't have new lines, so this sort of represents a new line. And then, yeah, so we don't need a new line there, I think. But, yeah, so we don't want that. That's the end. And then, yeah, we can add something like that there. And I think that is all part of the macro now. Should be. And then here we can do, I think you need to do something like that. Alright, so I'm not sure if that'll work. Perhaps I can open up a new file. So if I just test.c, and then I open up test.c, and let me just yank this macro and paste it in here. Whoops, getting too much. All right, and then let's see. There. There we go. Okay, so let me indent it properly. There we go. And then let's try to expand the macro. So name, and then compare as type as int. So let me, yeah, and then put the semicolon at the end. So let me call the C preprocessor on test.c. And okay. Yeah. Facing. Alright, so maybe that won't work. Let's see, what if... Alright, so... Yes, then that makes it a string, so that's not what we want. Let's see. Do... Alright, so is that valid? So let me try to compile this actually. So C test.c has. Alright, so that doesn't work. Yeah, because it's all underclared. So let me just try it in here. So I'll go up to the top and I'll just define it in here for now, and then we'll move it to the header file after. Right, and there we go. So as type. So let's try if that works. So let me go down and do compare. Yeah, and then we can do compare as type, and then as int, and then as float, as char, and as pointer. And we can see, oops, pointer, and we can see if that works. So I can get rid of all this now. Alright, yeah, so we don't have the... Alright, so let me see. Build it. Ooh, yeah, so I need to get rid of that. There we go, and let's build it now. Okay, so it compiles. So let me see if it works. So we have test.tasm, so let's compare. So, compare equal, and then print. Alright, tasm, Tim. Alright, so they are equal. Let's do something else. So 48.0.0. Okay, and then if they are not the same, 0. Okay, so that seems to be pretty good. Okay. Okay, yeah, so that seems to work actually. So I think we can use that now. So we still have the switch in here, so some of this stuff could be... Yeah, so this could probably be moved into a function. Yeah. Because this is all going to be the same across all of these. So if I just grab this, and then I'll just make a function somewhere up here for now. Can always move it around. Right here, sure. So let's do void compare types. I'll just call that for now, and we'll paste this in here. And now we can unindent this. There we go. Okay, so we need the machine. Machine. Yeah, and then this needs to be... this actually is data, and data. Okay, and then we push it back, then we compare it. In the compare, we also need the sign. So instead of this, we would do the sign. And I'm not sure if that'll work, but we can try it. So compare types, there we go. Yeah, and then we'll pass the sign in here. Ooh, so how can we actually pass the sign? That makes it a bit more complicated. Yeah. Well, so let me just, whoops, it's actually double. Yeah. Alright, well we can test if this works if we call this function rather than doing this. favorite all that, and then call compare types machine, and that's all that we need to pass there. Build it. Okay. Yeah. So I know what I did wrong there. This needs to be a pointer. There we go. Okay. And then I copied the extra break statement that we don't need. No undeclared. Yeah, so we don't have no in here. So we can I guess we could make them global. Yeah, and I don't think there's a problem with that. So actually maybe I won't for now. I'll just bring them into the function. Like this. So yeah. Alright, so now test.asm. There we go. So false, and then do like that. Okay, so now we need a way to get the sign in here. Because I don't want to use a different function for each one, because that is kind of defeats the purpose. So yeah, types. So I don't really want to add another switch statement for the sign, but yeah. Types really just make it pretty complicated. Yeah. So I'm not sure what the best way of going about doing this would be. Well, alright, maybe there is another way to do this rather than the separate function like this. What if we have a function that returns a value, let's see, based on this, and then based on different types. Yeah. Maybe we could do that. So instead of this, we would just return 0, return 1, oops, there we go. Oops, return 2, and return 3, and let's see, spelled this wrong. Return. There we go, and let's make this an int instead of a void. And then otherwise we just return -1. So then, yeah. So then, it's not much better, but we could work with this. And then get rid of these. And then call this function and basically have another switch statement. Yeah. So I'll need to think about how to do this a bit better. Basically, result equals that, and we'll need scope here. And then we'll do switch result. So we can have case 1, case 2, case 3, and we actually need case 0. And then also case -1. So that is the default. So we can break here. So this means int break, and break here as well. Okay, so then we can do pair as type, and then as int, and equals equals, and then this is a couple more things. So this one would be as float, and it's still equal, and then as char, and as pointer. Okay, and then basically we just have to do this more times. So this could be factored away as well, but whoops, didn't mean to do that. Okay, yeah. So let me just yank this here, and then basically put it into here. So this is not equal. Yeah, so let me get rid of all this stuff. And then this, yeah, can just be changed to this. So, yeah. So obviously, this, perhaps it could be a macro on its own. But yeah, for now, this will be good. Rather than having the one macro for this, yeah, this is good for now. So I'll just work with it. I'll work with this. There's not too many instructions, and this way we don't have to have a different instruction for comparing floats and all that stuff, and pointers and everything like that. Yeah. So this is greater, just like this. Wait, is that the right order though? So compare greater. Let me see. So this is less. Yeah, so that should be good. Because it'll use the correct sign. Alright, I will have to test this and make sure it works, obviously, but yeah, so we can place it in here. This is less. There we go. And then delete all these. There we go. Okay, and there we go. Yeah, so basically just doing the same thing all the way down here. No, greater equal, yeah, so it is like that. And then or equal to, no, and we need like like the logical operations as well, because I don't have any implementation of those. This is less than equal. So that is something that I will need to add. Alright, let me get rid of this now. Alright, and then that is all that we need for that. So, let's see if it still compiles. Nope. Alright, so, yeah. Issue is we need these. Completely forgot about those. Okay. And here as well. Okay, just like that. And almost there. So I can use one more after this. Right here. Yeah, and then the other one we did put that. So it should work now. Variable, yes, set, but not used. Okay, so where is that? Oh, here. Okay, so we don't use it. That was the only place that we used it. So maybe we don't need to define them here. Actually, that is in here. So why is it not used? Because it should be used. Oh yeah, we don't use it anymore here, so we don't need that. Yeah, forgot about that. So now that. All right, so let's test. Okay, 0. So that is good, and let's do compare less, and that should be 0 as well. But then if this one is less, then 0. Actually, right. So yeah, that seems to not work at all anymore. So I seem to have broken something. Cause okay. Yeah. So what is the deal with that? Compare less. Let's go to that. So less. So that's a little strange. Yeah, here is the macro that we're looking at. Yeah. So why is it not comparing it properly? It's just not doing anything, it looks like. Because it doesn't matter what order you put it in. It still is 0. So let's actually... So it should be an int, so let's just make sure we're even calling that. So we do. Yeah, so that is all right. It must not be expanding properly though. So let me go up here. Sign. So do you need to interpret this in some other way? This could probably be called operator instead. So maybe it is not being processed properly. So let me try here. Add op in op, and then put that in there. And then I will run the C preprocessor on test.c. And let's see. So that looks right, I think. Unless there's something else that it compiles, so that's not the issue, obviously. Alright, so we are checking the topmost element. and we're comparing it. So the top element, if it is less than the bottom one. So that should be true right now, but it is not. Let's see. So equal word, because that's obviously not equal, and then this is. Okay, now equal is not working. So yeah, seem to have broken everything. Yeah. So let me actually, can I add a print statement in here? I don't know if this will work, but true. And then I need to add that, and then add a false one in here. Yeah, false. And I need the semicolon still. Just like that. There we go. Whoops, that is not right. Okay, there we go. Build it now, and let me run it. False. Okay, yeah, so false. Yeah, and that should be false. So, let's see. So A and B, we pop the machine, we push it back, and compare them. So, let me print what is being popped. Actually, yeah, it's like that. We'll put it as an integer. As int, and b dot as int, like that. There we go, and build it again. I messed up. It needs to be dot word dot as int. There we go. Okay, build it. And now let's run it. So 48 and 48. Alright, so that is all fine. Turn 0. So we are returning 0 from there. So interesting. Yeah, and then we're coming back here, and then they just aren't being compared properly. Oh, because we don't have A and B here. Oh, yeah, okay, so I am make a stupid. So let's pass A and B here, and then we'll do A equals pop machine, B equals pop machine, like that, and then compare types. Yeah, I just completely made a stupid there. Yeah, so here, and then we don't need this here, and we need to pass them in here. So data A and data B, and then that should work now. Oh yeah, so now there's too few arguments everywhere, so we need to fix all of them. Yeah, so A and B. Alright. Oops. Data A, data B equals pop machine. Equals pop machine. Okay. Yeah, and then I will just, actually, since we're doing the same thing, I can copy this exactly. Alright, and then this should hopefully work. Whoops. Okay. And I know that this is not optimal, having much reused code, but right now I need to test it. Alright, so that is true now. And then if we change this, it should be false. There we go. Okay, and then we can do compare less, and that should be true. And then this should not be true. Then less than equal, that should be true. And then that should be false. Alright, and then we'll do compare greater than equal, and that should be true. Compare greater, and that is false. Or that's true, I mean. Now it should be false. And okay, so looks like all of that is working. And now it should work for the different types. So yeah, if we push like that, that should be false. Yeah, and this interprets them as an integer, so it prints out a weird number like that. And then if we do greater equal, like that, then there we go. Okay, so that looks like it's all working now. So that is great. Let me remove these print statements that I added, as well as, let's see, I guess I don't see, it is compare types in here. I have this as well, so there we go. And now when I run it, yeah, okay, it just prints out what we want it to print out. I can remove this test.c now. And let's see, I don't know. Yeah, so that didn't actually. Okay, perfect. So let me quit out of that tab actually. All right, so now we can infer the types. So what we should do now is probably add a way to cast it. Yeah, so like I was saying before, this was at the start. So basically int to float, something like that. So then if we have integers here, yeah, so if you have one float and then that, it'll take the top of the stack and then cast it to a float and push that back on the top of the stack. And then you don't get the weird numbers like we were looking at here. It'll actually just be 48.0 as a float. And that would be useful, obviously. Yeah, so I think I will add those. So we basically just right now need int to float and then float to int. Because the characters, yeah, I don't think we need anything to cast the characters, because that could just be interpreted as an integer. I think that should be fine. All right, yeah, so I'll add these. So it should be fairly easy to add them. In here, what is a good place to add them actually? Perhaps right after the comparison. So basically int, let's see, int to float, and inst float to int. There we go. And then we can handle it in the virtual machine. So let's do case, let's see, where did I put it? So after the compare less than equal. So compare less than equal, there we go. So right after this, I will add two new cases. Case, inst, let's see, to float, and then break, break, there we go, case, inst, float to int, there we go, break. Okay, so basically, we're going to take the top of the stack and cast it. So we want to pop it off, or do we even need to pop it really? We can just do machine stack size, and then let's see. Actually, maybe I do want to pop. So I'll just do a for pop machine. We're just working with one though, so we just need a, and then we can do a.word dot as int as float actually equals cast to double. I think double. Let's see, what is yeah, just a double. Okay, double of a.word.as int. And I think something like that will work. And then we can just push a machine a like that. And also we need to change the type. So a.type equals float type. Because then when we interpret it, yeah. So I think that is what we need to do. And then we can do pretty much the same thing down here as well. It's just we want to do as int equals int 64t this as float, and this can be changed to int type. Yeah, so let me make sure that all compiles. So it does not. So value. Oh, okay. Yeah. So yeah. So actually, we can just we'll just do a.type. Maybe we don't need to do that because yeah. So we want this to be a.word, and then this can just be the float int type. Int type. There we go, and then we'll do the same thing up here. So then, rather than doing that, this can be float type. Float type. There we go, and now, all right, it all compiles. So we don't have a way to test it, really, because it is not implemented in the assembly. So let's go to the Lexer, and let's add. Right after the operation, we'll add type, let's see, int to float, and then type float to int. And let me just make sure that is the right order. Yep, okay, and then we need to add it asm.lexer.c. Here we have the list of keywords, so we just need to add it in there, in the right place. So that is going to go right here. Yep, and then okay, and so we need int to float, and then float to int. There we go. And now we can open up the parser, Actually, we don't need to do anything in the parser. So we do need in the tags.c though, we have to add the instruction here. So inst compare, let's see, compare less than equal, inst to float, and then inst float to int. There we go. And there's no operand, so we don't need to handle that. And I think that should work now. So let me try, whoops. Let me try recompiling it. Alright, and then let's do int to float, and then they should be equal. So if we run it, okay, that's not 10. They are equal, okay, and then if we get rid of that, then they would not be equal. Yep, and so let's actually print the output of it. So float to int. There we go. So it actually, whoops, I need to close that. Let me run it again. Okay, so to int. That's kind of weird. So I'm not sure what that's about. It seems to have messed something up. Let me try int to float, and then make this like that. Whoops, I need to do that either. Hasn't, has not, hasn't. 10? Okay, ooh. Alright, so maybe that does not work. That is quite interesting. So yeah, it casted it in a very strange way. So that is not what I wanted. Oh, because this is actually a float. Yeah, so that is what I meant. Alright, 48, okay, and then int to float. Whoops, int to float, there we go. And make this an int. Okay, yeah, so it is working. So I must have gotten a little confused before. Yeah, because that is what I was expecting. Yeah, so then if we make it 0.5 or something, then we'll round it. Actually it just breaks then. Because it is a float. Okay, yes, so float to int, like that. Yeah, then it just rounds it to 48, and that is perfectly fine. That is expected behavior. So now this does make the types, so we can, what am I going to say? Okay, so now when we're comparing stuff, we can easily cast it between types, and then that's going to make things a lot better working with different data types. So yeah, so these, if we actually do float to int here, and then float to int there, and then we compare equal, then they should be equal. Yep. And if we change one of them, so if this becomes 49, then they would not be equal. Alright, perfect. So that seems to all be working. So I think this is good to actually commit the changes. So let me close out of that. Remove test.tasm and test.tim. And then I will go ahead and commit this. So let's see. So added type inference, I suppose is the term, to the comparison instruction, and also let's see, what was also added cast instructions for float to int and int to float. There we go. I will push that. Okay. All right. And then make sure it's worked. Internet is slow right now. Let's see, I think, yep, perfect. Okay, so now I'm going to be right back for 2 minutes because I have to go to the bathroom really bad. So break 2 minutes. Yes, break for 2 minutes. Yes, I will be right back. Okay, I am back. I apologize for that. Okay, so now I'm gonna actually let me quit out of this, and then I will build all the tests that we have. It doesn't actually check them. Make sure they still compile. And let me actually make sure it all works. Let's try fib recursive. All right, and that one works. Okay, and iterative. Okay, yeah. So that all seems to work. Yes. So I need to update the recursive one because it is rather slow because I'm using loops and everything. Okay, so now, I think it would be valuable to, let's see. Let me move this actually into 10.8. Down by, we have other macros in here. Oh, I guess I got rid of them. Okay, but we do have this one. So let me actually put it above that one. There we go, and make sure it all still compiles. Okay. Yes. So now what I want to do is actually, I want a way to get the pointer to the element at the top of the stack. So what I'm thinking is it will take the element without popping it off. It'll still be there. And then we'll just push the pointer to it right at the top. So then you can do stuff with the pointer. So I think that would be a valuable thing to add. So that's going to be an instruction. I think it could be, let's see. Actually, we already have push pointer, but it's not an actual instruction, I don't think. Let me look in Alexa.c and go down to here. We do have push pointer. So what does that do? I don't know that I handle that actually. Push pointer. So I don't remember actually. Because I use it for other stuff, for the string, but for the actual, I guess we do have that. So I don't remember what I did. Let's push pointer. So yeah, all right. So I guess we can define it. Let me open up. Let's see, I don't have that anymore. So let me test.tasm and then open it up. So push pointer. What happens if I do that? Okay, and it just so the IP that value. All right. Pointer 1. Because I was thinking about repurposing this, but now I'm not sure. Yeah, so it doesn't want that. 1. Okay. Yeah, so it doesn't. Alright, yeah, so that is kind of strange. Strange behavior. And I'm not sure that's what I want. Let me actually just print that out and then see if it's actually used anywhere. So we do use it in this one that I just wrote. But it doesn't actually print it out. Oh yeah, because I got rid of it. Push pointer. Okay, recompile that. 10. Alright, yeah, so it does use it there. But then if we go to fib iter, yeah, so it doesn't use it anywhere there. So I don't think I used the instruction for anything. So I think we can repurpose it to basically do what I was talking about. So instead of taking the value, we'll just take the top of the stack. So basically, A equals machine stack stack size. Yeah, so that's basically what we want. So A will equal that, and then we can push the pointer to A. Yeah, so pointer to A. Something like that. And I think that should work. Word, but argument. Alright, so. Ooh, yeah, so I'm gonna need to modify the push pointer. Or can I do that? So do we want it to be that? Stack size is undeclared. Alright, yeah, is this a machine stack size? Like that. Alright, and let's see. So that, let's see what it does now. Okay, so, and then we need a way to dereference it, I suppose, as well. Because then we can just have two of, yeah. So, do we want get pointer? Is that an instruction we should have? Well, let's see, I guess we could. I suppose we could print the top of the stack. So after this, just basically print f, and then dereference the element at the top. Let's see, and then dot word dot as pointer, and then we do something like that. Yeah, it doesn't like that. Because it is a void pointer. So let's actually cast it to an int. Let me see. Something like that. Alright, ooh. Yeah, int 64, whoops, t, like that. Alright, and now let's, alright, then it's say false, so it doesn't like that. So, dot word, can I do, let me see. Can I convert, yeah. Alright, I'm not sure how to do this, actually. So, yeah, so dereferencing it would be, let's see, when we push it, push pointer, whoops, and that is not the push pointer, and let's look at the definition of it. So, we set the as pointer equal to the value, so that would be the value that we pushed. So then we should be able to just get the as pointer and then print it, right? Well, dereference it. Yeah, so let's see, can we print the pointer? And then, so let's run that. Pointer is nil. So right, yeah, actually, so this might not be valid, actually. That might be why, because we need to use x minus 1 because of the way it is handled. Yeah, so let me try that now. And now, yeah, these are equal. And if we do this and we cast it to for t pointer and then dereference it, then build it, then alright, so yeah, it doesn't, yeah, this needs to be like that. Build it, run it, okay, and then 1. So that is actually correct, right? Let me make sure that is what I put. Yeah, so 1, and if we change this to 3, then we recompile it, run it again, and then 3. Okay, so that is what we want. So that, yeah, so it's just an off by 1 kind of thing. So now, yeah, so we should have probably get pointer. Maybe this should be, maybe it should be renamed. Where instead of push pointer, it's like well, get reference and then a reference and dereference. Yeah, maybe that is a better idea. Yeah, maybe I will change that. Should I add new operators for that and then put this back to how it was though? Yeah, let's just do reference and then dereference. And then we do need to change that in here. So, let's see, push pointer. So ref and then deref. And then in here we need to change where we have push pointer. Okay, so that is actually going to change a lot of stuff. So this needs to be, yeah. Actually, yeah. So we do use that in here. Oh, I forgot about that. When we push null. So yeah, I need to actually go back. And then just put this back to the way it was before I started messing around with it. And I don't remember exactly how it was. Whoops, already had all this change. So push, yeah, so that is how we want that to be now. So I'll make new instructions for it. So this will be after get stir, I suppose. So we can do case inst reference. and then case inst dref. Yeah. So, because that serves a different purpose. So, let's see, that goes after get stir. So, inst ref, inst dref. There we go. And then we can modify this in here. So, we have push pointer get stir, then inst ref and inst dref. Okay. So, we've got that. And then, yeah, so this will be ref. So, in here, we can add, right after this, we can add see if I did that right. All right, yeah, so ref and dref. Dref, there we go. Ooh, okay, and that just did that. So let me do something like that. Yeah, that's good. Probably format this a little better, but it is all right. And then in the PESMLexer.h, we need to add that in here as well. Type ref and type dref. And then, yeah, so there's no operands or anything. So I think that might be all that we have to do. Let's build it, and then let's try to compile this. Chasm, and then 3. Okay, so yeah, we didn't actually implement it, so it is just printing 3, because it didn't do anything. Let's make sure they're called then. Let's see here. Actually, let me just assert false, and not implemented. All right. Yeah. So let me do that, and then I'll do that here as well. So I will build that. Okay, false and not implemented, and then if we put dref, then it should be the same thing. Okay, 418, and that is correct. All right, so now we can implement it the same way that we did. So a equals, excuse me. All right, machine stack, machine stack size -1. And then we want to, let's see, what did I do? So we want to push pointer, machine, and then a dot word. Let's see, but the pointer to that. And then, let's see. So we want to, yeah, we want to do a dot, a dot type equals pointer type. Yeah, and that should work now. So let me build that, and if I did everything right, alright, so we still have the dref, so let's do that, and then, okay. So, why is it, oh, I need to recompile it actually. There we go, and alright, so that should be the pointer to it, and then here, we can do sort of the opposite. So we take the top, and then the type equals, I guess we can't really get the type of it, can we? Well, I suppose we could actually, perhaps. If we get that, and then we do, so since we change it to a pointer type, that does make it a bit more complicated. So we need to get the reference of it, so equals a.word.as pointer. Let's see. So something like that. Dot word or dot type. Let's see. There's something like that word. Perhaps, perhaps not. And then this we just want to push a dot word. There we go. And actually push a dot word and a dot type. Yeah, okay, so let's try that. Alright, yeah, so it doesn't like that. Word. Okay, alright, so what is a different way of going about doing this? Because I'm not sure that works. A dot word. Yeah, I'm not sure about that. So I guess because could it still be just set to a pointer type? Would be a, I will figure it out, but let's see if that even works. Okay, so we get the pointer to it, and then let's deref, and then let me recompile it. Test.in. Okay, so deref, and we get not the right thing. So it's not what we want. Do I not push it? I do. Oh yeah, so we need to dereference this actually. Yeah, so let's do that. Word.add. So maybe we can't use a here because that is. So let's make it a pointer. Actually, it should be a word pointer. Word. No. So what can I call it? Just pointer. And then we can do pointer, and then let's see. So let's do word.add. So here we'll just cast or set the pointer type, and then here we can just do something like that. All right, and let me see now. All right, 3. So that worked then. 3, and if we change it to 9, and then we compile it all, 9. Okay, so that seems to work, but it does think that it's a pointer on the top. Yeah, and let me print all the way down. So we should have yes, we have those. And I think that these are the same, right? Oh, well, this is a pointer to it. So, let's see. Should I pop it off the stack, though? Instead of doing this up, just pop it from the stack. Should it get rid of it when you dereference? Get rid of the pointer. Probably not. We should probably leave. Well, you could duplicate it, though, if you wanted to keep it. I'm not sure. For now, I won't. For now, I will leave it like this. Okay. So how can we get the type from it? What's a way of doing that? Let me think. Well, perhaps this is something that I can commit now. So added instDef and deref to get to reference and dereference an element on the stack. Okay, and then push. So I think that's all I did. So whenever it decides to go, there we go. And then see. All right, refresh. Okay, and seems to be good. All right, so yeah, so what is the way that we can get that? So we have, let's see, if we make this data pointer, and we get this, so that won't work though, because it's trying to receive that, but this is not a pointer. So let's see, pointer word like that. All right. Let's see, pointer dot word. Let's see, actually put this in here. Okay, and then let me see what that, whoops, not what I wanted to do. Go. Okay, yeah, so that messes it up. So that is not what we want, because we're not getting the pointer correctly. So we want to get, yeah, we want to get the top of the stack. So it is a pointer. But yeah, so let's get that. Pointer dot word dot as pointer. Actually, we can just do the word, right? Because that is inferred. Yeah, but we want to actually and then like that. That doesn't work. So let's see. Word ref equals pointer dot word dot as pointer. And let's make it a that. Mm, okay. Unused variable. So this can be like that. Okay. Expected. Okay. Got a semicolon. So then that compiles. It's still not quite what we want. So we can get that, but then we need to get the type of it. So ref dot type. So that is just going to be a pointer type, right? So oh, because that's a word. So I want to get the we want to get what it's pointing to and get the type of that. So how do we go about doing that? Well, so we can get what it's pointing to. So we can do something like a equals the data is what contains that. So it needs to be a data. And that is pointing to data. So what if we do word a equals ref. Yeah, so that's a word. So that doesn't work. So yeah, I'm not sure. I don't. I will look into that string. So I will work on something else right now. So this, let's see, we want to get the pointer.word.as pointer. Let's see, is this how we were doing it before? There we go. And this can be pointer type. Let me see, build that now. Alright, that doesn't work. Because, yeah, so let me just go back to doing this way. So ref equals pointer dot word dot as pointer, and then here we will just do something like that. Okay, and then run it, and that is expected behavior. Okay, so we can get the pointer now. So I wanted to try something actually. So if I push character, so we'll just say 0, and then reference it, and then push 1, and then call native 1. Okay, whoops, I need to recompile it. Alright, so it does print it out. So that is, yeah, so now we can actually print out characters like that, which is something that we needed. Because here we have the int to stir right here. And this basically takes an integer, of any integer. So it can be negative 1000, that's only 100, or it can be positive 420, it can be whatever. And then if it's less than 0, then it's negative. So we do that, and then we set it to the negative version of itself. And then if it's greater than 9, we divide it by 10, and then we call this function again with a new value, but then it still continues here. So then this will basically take, it can take anything. So if you have 10, it will just pretend it's 0, and it will convert it to 0 in ASCII form as just a single character. So I think we have enough to implement this in our own assembly, because that is sort of what we were missing there. So if we make something like into stir like that, and basically we just print out each individual character with the right syscall, which maybe isn't the most efficient way of doing it, but we can do it like that for now. So basically, so we push something to the stack initially, so whatever we want to print. So we'll just say 100 or whatever, right? So first we need to check if it's less than 0. So we can push 0, and then the compare less is not what we, well, if we swap it, we could use that, I suppose. So compare less, but we want 0 to be on the top, so we won't swap it. We will do compare greater. So if 0 is greater, then, yeah, so we'll 0 jump. So if it's not greater, then we'll not negative, and then we'll just make a new label called not negative. But otherwise, we will do this. So basically, we'll write, see, we can just push that, and then push 1, and then actually we need to ref, and then write, well, actually we'll just do native 1, because we don't have the macro for that, and that will print that onto the stack. Then we can pop here, because we're going to pop the 0 off. And then, then we need to check 9. So we'll push 9. And then it is if x is greater than 9. So we'll just compare less. And 0 jump, let's see. Less than no. Which there's probably a better name for that, but that's what I'll call it. And then, so we need to basically duplicate what's on the stack and then divide it by 10. So let's actually pop 9 off and make do. And then push 10. And then div. And then we want to call this again. So call I2 stir. Yeah, and then less than 9. Okay, so otherwise we go here. So we need to pop again. Let's see. And then we need to do this. So basically, this is mod, the number mod 10. So we can do that. So if we push 10, and then call mod, and then we want to add 48, which is the character value of 0. So yeah, I'm just gonna make sure it's 48 to avoid any problem. So we do that, and then we want to write it. So we can just want to write it as a character. So we can ref and then push 1 and then -1, and then we can just return. And let's see. So if I did everything right, then that'll work. But I almost definitely did. So let's make a main, and then let's push 5, for example, and then let's call I2 stir. This actually needs to call, and then at the top we can do entry point main, and let's try to compile that. Okay, so it compiled, and it actually printed out 5. Okay, so that worked. Let's do a -5. And it prints out -0, so that is not right. Yeah, but let's try 50. It does print out 50, so what if we do 1,000 or 10,000? So that does work. We don't print a new line, which we should probably do. It's kind of hard to tell when we would do that, though. Okay, well, so yeah, so that works except for negative numbers. So why does it not work on negatives? -0. So we print out the negative. Do we need to pop something off here? Is that what I forgot to do? So when we call this, it gets rid of everything that's on there. So that should pop it off here. Alright, what if we pop first? Does that break? It doesn't do anything. Let's see. There. That should be an underflow, yep. So yeah. I'm not sure. So we get here. Let's see. So we do this all properly. And then we reference that, we print it. So we're printing that. And then here we pop off the 0, which is going to be on the top. So that should get rid of that. Then we push the 9 and we compare it. Let's see. And we do pop the 9 off. So that should be fine. Then we push 10 and we mod. And then push 48. Add. Reference. Okay, so I'm not sure why it's not working. Why it does not work like that. -1. It just becomes -0. So yeah, it doesn't like any of those. It could be with the way we are interpreting it, perhaps. And I think we can do a new line where if we basically make Inktoster implementation, which that's kind of a long name, but then we just take everything that we have in here, and then we just then we put it right there, and then we call that from here. Yeah, so we call Inktoster imp. I'll just call it imp instead of stir imp. Okay, yeah, instead of implementation. Yeah, so something like that. And then before we return here, we actually push a new line, and then we do reference, and then we push 1 and -1. Then that should print it with a new line. Yes, okay. And it should work with any of them. Okay, it does not. So, ooh, yeah. 1975. So why did it print that? Okay, that is kind of strange. 1975. So Alright, so maybe that doesn't work. Yeah, so if we call this directly and it prints out properly, no. So something broke by moving it here. Okay, because it was working. We were doing that and it was working fine. But now it is not. So I'm not sure what happened. Let me get rid of this. And then make this that again. And now actually that is undefined because there we go. And then do that. Okay, and then it works. So that is okay. That is fit string. So I don't know why. Yeah, and we can't just put a new line at the end here because we actually come through here multiple times because this is the only place we return. So when we call it here, we actually go back through. So actually, I was thinking, I'm gonna actually rename some of this stuff. So anything that is not like gonna be a function call, I think we should prepend with an underscore, because that way we know. Let me make sure. Yeah, so it still works. So I suppose we can just print the new line here, and then need it one. We need to push one first. Actually, we have to do that afterward. Yeah, okay, so that works. Yeah. So let me just kind of okay. And yeah, so that all works. So it does work. Just not when we become negative. There's some oh, you know what? I know what it is. We don't set it to the negative version of itself. I completely forgot about that. So basically, yeah, if we actually push 0, and then we actually we need to pop first, and then sub, and that should subtract it from itself. Yes, that's not. Let me print what's on the stack right here. Alright, so 45 is on the stack. So where is the 45 from? Oh, okay, so that's actually the negative that we print. Ooh, so why is that? Oh, you know what? Because we need to pop that off. Okay, yeah. So pop, and then what is on the pop? Then we have, okay, yeah. Because I forgot we don't get rid of it when we reference it, obviously. So then we get an underflow. But then we have 0 on top. So yeah, so if we do something like that, and then we swap. Shoot. Alright, so if we put what's on top there, then we get the number. Okay, so that's actually how we want it. Well, that's not how we want it. We want to not swap. Then if we print, alright, so maybe we need to actually swap here. No, swap before we do that. And then, yeah, so then that should be on top. But then we need to swap it again. And we still underflow. Well, yeah, because we print it actually. So -0. Alright, so here we pop off that, and then we swap, so there's going to be 0 on top, that is this 0. And we swap it with the other one, and then we push 0, and we subtract, so 0 minus that one, so it becomes the negative version of itself. Which is what we want. And then we swap it again, and then it should work after. So if we then we get the right number. So, but it's not negative actually. So that is yeah. So why is it not okay, so we want to subtract. I'm gonna swap this first. Okay, there we go. Yeah, and then we don't want to print it. And there we go. Okay, now we can print. Alright, that was a bit of work. But now we can print negative numbers as well. And I can just make sure it works with all of them. Like that. 1319. Okay, so that is pretty cool. And we don't actually use strings for this at all because it's all character based. So yes, I like that quite a bit. I just wish we could do the new line. Print a new line. So, yeah. Alright, well this is good. So, stir. Yeah, because now this is a native function, which we had in here, which we don't need anymore. Because it returns the stack, so anything on the stack should be removed. So let me actually print here, and that should be an underflow. And it is not, so we have 10 on there still. So we need to actually, why do we have 10 on there? From this? Or no, that's the new line. Oh yeah, because we need to pop off that. That is actually just, that's something that we do in here though, so that should be fine. If we don't do that, because we don't have to. And then we print. Then it should be... Alright, so we have 9. So we do need to pop off the 9. Where's the 9? There's 10. There's 9. So that should be removed from this. Yeah, so that shouldn't be there. So what is it from? Yeah, because we don't want anything left on the stack. So let me just print all that I can. See what we have on there. Okay, so we just have the 9. So what is that from? Or 57. Alright, so it's the character of 9. Yeah, so it's that last one that we have. So actually, do we just want to pop that, perhaps? No, it's that phrase stuff. So, so we want to pop right after we return. Yeah, we'll just do that. Yeah, so that is why we need like the intermediary function, essentially. Which is what we tried to implement before, but it didn't work. Let's do id_stir, and then we call convert. That's just what I'll call it for now. Call convert. I want to return here. And yeah, so then we pop. So yeah, so if I rename this to convert, then you know what? It wasn't working because we actually call it in here. And that is why we were getting the issues. Yeah, I think that was it actually. Okay, so we get a stack underflow from this. And let me actually push new line, and then push 1, actually reference it, and then native 1. Okay, so we can do that. And now, alright, we do actually pop it there. So we want to pop, pop and pop. Let me actually pop up here, rather. And then there should be nothing left on the stack. So if we try to call pop here, then it does not work. Okay, perfect. So now we leave the stack completely empty. So it would be nice to push it as a string, but for now I'm not going to worry about that. Basically, this is just printing stir. So maybe that's what it should be called. So print in. Yeah, print in. That's what I'll call it. Print in. And then this can just be, yeah, we'll just call it convert. Yeah, so then we can actually move this. We should be able to move this. So, yeah. Let me just make sure it's all working. Alright, so that looks good to me. So let me move test.tasm to test/printint.tasm. And then, yeah, so that should be in there now. So let me move test.tasm. Well, it's test.tin. Test.tasm does not, oh, because I moved it. Yeah. So obviously it doesn't access anything. Let's open printint. And yeah, so we have that in there, so we can run. Actually, let me import standard defs.dash. And then we can replace this with route and this with standard out. And let's see, where else do we call native? Reference, yeah, so here, standard out, and then right. And here as well, we do that. Standard out, and right. And there we go. Okay, so now if I test slash, actually I have to cd into the directory, so hasn't, let's see, so this is print int higher print int Tim. Alright, so 1319. Okay, so it prints it properly. So now let's see. So that works, and I don't think I call native anywhere else. So yeah, nothing else that we can do with that. Yeah, okay, so that is pretty good then. So now we have this example, which allows us to print an integer. So let me actually get rid of the main in here, and then get rid of the entry point. And what if I, just temporarily cut test.tasm, and then open that up, tasm, and then import, import printint.tasm. Yeah, so what if I do that, and then, main, so, main, and then, push 1, 2, 3, and then call, let's see, it is printint, and what happens if I do that? So, that's not tasm. Alright, okay, so it doesn't like that, printint 45. Okay, so it doesn't like that. So I think that it is something to do with this. So let me actually, what if we don't use that at all in here? Yeah, because it gets a little weird when we do that. Yeah, so here, same thing, 1 and native 1. So basically just undoing what I just did. And then, yeah, whoops, and native 1. Alright, so now let me try that. Alright. Actually, that's not what I wanted to file, so, yeah. Alright, so it still doesn't like that. Expected non-type, but found labels. So, yeah, so I think, it is an issue in the preprocessor. It doesn't want to expand properly. If I do that, alright, and then, stack underflow, okay. Why? Why did it do that? I'll print in. You know what? I need to move this to the top, actually. There we go. Okay, 1, 2, 3. So it did work then. Yeah, because this needs to be on the top, because otherwise it expands this here, then it tries to call all these. So, if I add that to the top there, then it won't compile on its own, but then I don't need that there. I think it's better to have it in the function that you actually use it, though. So that is fine. Yeah, so that does work, it would seem. And there should be nothing left on the stack. Yep, perfect. Okay, so yeah, we can sort of use this as a library, essentially. And it just takes what you have on the stack and then prints it. Yes, so I quite like that. Yeah, so this is sort of part of, like, we can build a standard library now. So that's pretty cool. So I think I will, move test.tasm to, print example.tasm, which is kind of a long name, but yeah. And then actually I can move printint.tasm to printint.cache, because it is a header file, and then open up printint example, and then change that to that, and let me try to compile this. Let's see, printint example. All right, printint example.tim, and it works. Okay, yeah, so perfect. So let me just put random number in here, and then there we go. So it works. That is very cool. Okay, so I think that is good, and that is enough that I can close out of that. I will push this actually. So basically, I just added the example here. Git add, git commit. Basically added example for printing an integer. Rather than without using the int2stir native function. Alright, and then I will push that. Okay, and if I take a look right here, and it worked. Okay, perfect. So let me do git clean, and then let me make sure. Okay, so and then let me build everything. Make sure it all still compiles properly. Okay, looks good. And now let me get clean again because I don't want all that stuff. Okay, so now let me look at the to-do list actually because I have this. So we have that now. So we have test turn completeness. I'm not going to do that right now. There was something else I think that I wanted to do. So I can actually just get rid of these ones that we did now. Yeah, so let me see. Why do I have that? Oh yeah, because that was in there. So do I have any? Alright, so that's all good there. So now I think I will add look down here, we have inst add, for example. We have different operations for floating point, and I think that makes sense in terms of arithmetic like this. So I'm going to leave that. Even though we could just infer the type, essentially. But you can see all of this is actually doing the same thing. It just has a different symbol. So we can actually, we can make this a macro, much like the other one that we made. So let me define, this is essentially a math operator, I suppose. Something like that. I might change the name. And we need, we need what? So we need as int. So the type essentially, the operator, as well as the data type. And this can be as type, and then this can just this will be data type. So we'll call it that, and then I will do this, do 0, something like that, and then do like that. Okay, and then we can add all this stuff in here. So a equals pop machine, and then b equals pop machine. I actually want to do that in the opposite order, and then push machine word, and then a dot as type, and then operator. Yeah, so operator b dot as type. Actually, this needs to be word dot as type. Like so, and then we have this, and then data type. Okay, so something like that. And then if I actually do that like that, there we go. Then this indented. Whoops, I need to do it like that. This should be hopefully valid. So let me, might need to fix it up a little, but if we, yeah, so I actually wanted to get rid of it, so I guess I did not. Yeah, so let me just do that. There we go. So let's try that. So add, so let's do math op, and we need add int plus, and then int type. Alright, so let me try that. Let me make sure actually, yep, okay, so let me see if it compiles. Okay, it does. And then let me just make a simple test file. So I need to actually create it. Test, and then let me open it up right here, and then we'll push 5, push 3, and then add and print. Yeah, so we'll do something like that. Compile it all. That's not 10 and 8. Okay, so that looks like it worked. So let's try it with sub now. Yeah, so it's still an int, because this is the int one. And yeah, int type. Alright, so that is all good. So let's build it. And I need to actually change this to the sub. So that should be, well actually, yeah, that should be 5 minus 3, I think. And 2. Okay, so that all seems to work. So I think we can do this. Change this for all of them. And this is divide. So there is one. We do need to check this actually. So B is actually on the top, so we can just check if the top is equal to that. Yeah, and that should be fairly easy. So instead of B, we do machine stack size, I think we want -1 though. Let's see, dot word dot as n equals 0, and we can do that. Yeah, so, yeah, that should work then. So we have that. We actually need the same check for mod, but I don't think we have that at the moment. Yeah, so get rid of that, and there we go. That should be the same, and just change this to mod operator. So let me build that and make sure it all compiles, and then let's check. So if we push 0, and then make this div, we run that. Cannot divide by 0. Okay, perfect. So that is what we wanted, and then that should be 5. Alright, perfect. So that looks like it works. So now we can do pretty much the same thing here, except we make it as float, and then still plus, and this is float type. Alright, and then we can do the same thing here, but subtract, and then multiply, and this is divide. There we go. Okay, so alright, and then that's float. Okay, and then we have mod. And we don't actually check here, so maybe we don't need to check. I don't know. But this needs to be a little different. So mod might not actually work because, yeah, it actually works different than the other ones because it's a function that we have to pass it to. So I think we'll just leave this one how it is for right now. But yeah, so if we compile that now, whoops, let me try this. So 1.0, 5.0, and then div f. That's not Chasm. That's not Tim, and okay, so that looks like it works. Yeah, let me do mod f. 0, okay. Yep, that is correct actually. And then what if we do that? Do that. Yeah, infinity. So we do actually want to check that. Just like with the other one. So dot as float though. As float equals 0.0. Yeah, and then why are we doing this twice? Oh, that is the mod. Okay, yeah. So yeah, let me get rid of that. So that is messed up actually. We want to do this here as well. There we go, and build it. And then now it should say cannot divide by 0. Yep, and then mod f should say that as well. Cannot, yeah, so cannot, it's still dividing, is what it's doing essentially. So that is all good. Yeah, so now that is quite a bit cleaner because we don't have all that same stuff, all that, repetition essentially. We may be able to use the same one for another, let's see, so the comparison, I suppose the comparison is essentially the same as that, though, isn't it? Because we pop it, and then we just compare rather than... Yeah. Yeah. But we check the types on those, so... Because that way we don't have a different, like, compare float. Like that. Whoops. Like that. And I think it's probably better that way. Yeah. So, let's see. Is there any other one? That just has 2 operands in that way. Yeah, so this, actually, I'm gonna rework. Not right now. And we have hold. Okay, so all of that seems pretty good to me. So, that is quite a bit nicer. And I think perhaps we should have error messages as well. Could just be, like, because this is just the same thing over, the same 2 lines. So I think we could do something like, at define print error, and then we just have the message essentially. Whoops, and then we can do fprintf standard error, and then message because it will be quotes, and then yeah, message, and then exit 1 with no semicolon at the end, something like that. I think that would work. Let me try that actually. We don't need the new line. Yeah. So let's just go somewhere where we use fprintf, that we can easily, let's just do the divide by 0. Yeah, div f. So yeah, let's just look at this one. Let's do error. Error can not divide by 0. And then build it, and it does work. So let's do div f, and then try to do that, and okay, so that seemed to work. Let me just make sure it was one exit code. All right, perfect. So yeah, then we can use that, and it's just one line instead of two. So it's not like a big difference, but it is a little bit. So same thing there, and then up here as well. So that should be all good. Here, just went right past it. Okay, and then where else do we do standard error? Cannot jump out of bounds. Okay. Cannot, let's see, jump out of bounds. Same thing here. It's actually the same message. So, error as well, same thing. And actually, I think we have that for all of these, right? I guess that was the last one then. Alright, so, standard error. Standard error. Alright, here, we can do that. Alright, so this is actually a little different because we have an argument with it. So I don't know that we can use that. Yeah, so I won't use it here. Yeah. Which I guess a lot of them do, but some don't as well. So this was, what was that? Stack Overflow, okay. Stack Overflow. There we go, and it's the exact same thing right here. So was that? Yeah, that was Overflow. And then we should have a string stack overflow, okay. String stack overflow, okay. This is stack underflow. So that is a little different. Okay, and now string stack. Okay, and that should be it for the stack overflows. So let me see, error, index out of range. Okay, so we can do that. Error, index out of range. There we go. Same thing here. Same thing there as well. Okay, I guess same thing there too. Whoops. So yeah, error, stack underflow. Okay. Error, and let's see. So could not write to file. Yeah. So that's what this is. Could not write to file. There we go. Okay. Error. Could not read from file. Okay. Could not read from file. Okay. Then string stack out of bounds. String stack out of bounds. Maybe not the most helpful error message, but it is fine. Alright, and let's see. So shouldn't be too many more. That seemed to be it actually. So I think we are good then. Just make sure it all compiles. Okay, and I'm going to trust that it worked because the one worked, so why would it not? Yeah, so now we could probably actually commit that on its own. Whoops, did I? There we go. Like that. Build. And then git, let me actually remove test. And then git add dot. Git commit dash m. Added macro for error handling. Push that. And now did not work. Okay. So something did not work out, right? Let me try that again. Okay, so I think I broke something. Oh, is my internet out? Something happened, and the repository doesn't exist anymore? GitHub might be broken actually. Yeah, none of my repositories are working. Yeah, okay, it looks like GitHub's actually broken. So we can't actually push that. That is good. Okay, that is cool. Yeah, hopefully it comes back. Yeah. Yeah, that is kind of funny actually. For a second I thought they banned me from GitHub. Pull request. Let's see, Git operations. Partial outage. Okay, yeah, so it's down. So yeah, so we can't push that right now, I suppose. What is something else we could do though? I think quickly I'm going to take another break and go to the bathroom again. So yes, quick break, 2 minutes. Alright, I will be right back. Okay, I am back again. So let me see if GitHub is actually back. I'm assuming not yet. Yeah, okay, it is still not working. So let me actually, I was doing some thinking. So we can't push that right now. That's okay. I think, what we should do is perhaps add a way to essentially, index strings, because that's what we need to be able to do. Because right now, we can't really set the index of a string. Like in C, obviously, you would treat it as an array, and you do something like stir index equals a character, right? And you can't do that. Really, you can add to it. You can get the index, where you basically get the pointer to the start of the string, and then you just add to it. So you do, this is actually in the, let me create the file. In here, there we go. Okay, so you can put a string, and then you can actually get the string. That gets the first string on the stack, so it is that one. And then you can actually push 1 and then add, and that will get the next index of it. So then if we write that, then it will write the current index. So yeah, so this is actually -1. And then if we run that, then you can see it's est. We don't have a way to set that. So that is something that I need to do. So I'm not sure how I would go about doing that exactly. But a start would probably be another way to get strings on the stack. So basically, if we have a character, then we could reference it, right? And then I was thinking we could do something like move stir, and then whatever's on the top of the stack, it will put it on the string stack. So we could do a character pointer like this, and that would be the same as a string, just essentially a one character long string. But it does need to become null terminated. So we could set that in. Yeah, so actually I don't know how we would do that. We need some way to null terminate it because it wouldn't work without that. But also, then if you had a string on the stack, so you do get stir, you could move stir that one and then put it back on the stack. Yeah, so basically that is what I want to do. So let me add an operation, and let's see. So get stir and then move stir. So let me handle that in here. So move stir. We don't have that. Get stir. Yeah. So right here, case inst move stir. Right. All right. So I'm not sure what we do with that exactly yet, but in the lexer, let me add that. Type move stir, as well as in lexer.c. Stir. Yep. And then move stir like that, and then let's open here and add right here inst move stir. There we go, and that should be all that we need. And then if we just assert false here, and then in here, let me just do that, and then push one, and then reference, and then move stir like that. Build it, and him, and there we go. It worked. Okay, so what are we going to do for this? We're going to get what is on the stack and pop it off. So basically, we can do a equals pop machine. All right, so now we have the pointer to it. And then we want to push stir. Push stir. So how do we actually use push stir? Let me look at push stir implementation. So we have the machine and the value. Okay, so we need to interpret it as a character. So if it's not a valid character, there's going to be weird stuff that happens. But that is just user error. So then I think that should be all that we need to do, is just push the stir. So, yeah, so push stir, machine, and then a.as pointer, and actually we need to do a.word.as pointer, and cast it to a char star. There we go. And let's see if I build that. And then run, okay, test.tim. Okay, so it didn't do anything, but then let's actually get stir 1 and then push. Let's just print actually for right this second. Do that. String stack out of bounds. Okay, so that it looks like it did not work. Instead of printing, let me do push 1 and then native 1. Alright, so okay, that is a... Oh yeah, because we don't have any strings on here. So that would be the first one. But it doesn't look like it worked. So if we... What if we do push stir 1, like that. Oh yeah, because it's not null terminated, so it freaks out. But so if we push stir 1, and then let's not reference. And let's get stir 0. And then move stir, and that should basically duplicate 1, okay? And if we get 0 as well, it should be 1. So we have 2 now. So that does work. We just need a way to... Basically, we want to be able to push characters and then combine them together. But it does need a null termination. So, I suppose what we could do is... temporarily at least, we do if a.type equals char type, then we want to do let's just do char star stir equals I don't know, is that what we want to do? Let's do perhaps so else we just push this as it is, otherwise yeah, so I'll move this up here. So we'll do that, and then we'll basically stir 0 equals a.word.as char, and stir 1 equals a null termination. Because then that's just sort of a temporary way to do it, and then we can just push the stir here. Stir like that, and let's see if that compiles. All right, and then let me do that. Not get sir. All right, and now let's run that. All right, so we didn't. Okay, because this needs to be regular push, and then run that. And it's segmentation faults. Okay, so that didn't work. Let's see, where did it seg fault? Is it in here? I think F here. Let's see if we made it there. Or yeah, this one. Tire. Rebuild it actually. So we did not make it here. So it is something to do with this. Oops. Yeah. So. Alright, so it actually is before this. Alright, so we get here, and then it doesn't want to check the type. Oh, is the type not set? Ooh, that could be an issue. I mean, it should be. Let's see. Yeah, because this gets the element on there. When we push it, let's push. We are setting that. Let's see. So we have char type. Char type. Yeah, we have this. So what is the issue? What is the issue here? Let me print a dot type. So is that what the issue is? 0. Okay. The type should not be 0. So that is not right. So we aren't setting the type properly. Okay, let me look in tasm.c. Actually, I already have that open. Yeah, so let me quit out of that. And in here, type char. So, yeah, so we're passing it as int type. We want to pass it as char type. Yeah. Okay, so I think... Okay, that still doesn't fix it. Because we didn't recompile it, actually. Let's start tagging, and then run it, and there we go. Okay, so then it worked. That is perfect, actually. So let me not print that out anymore. Build that. Run it again. So there's no new line. But we don't want to insert a new line by default. But basically, we can do that now. So we could actually make this just a new line. And then run that. And it just prints out a new line. So that is good, actually. Let me check GitHub. Okay, it looks like it's back. So, let me try to push this. Git push. Without any extra commits. This is just the commit from before. Okay, and it looks like it probably worked. 14 minutes ago. Yeah, okay, so that is the commit. Alright, well, so this looks like it works. So we can, yeah, move the stir. So obviously, you could do weird stuff with this. Actually, though, we want to reference this, right? Yeah, so that's why it wasn't there. But if we reference it, then it does weird stuff. So, yeah, then it gets messed up. So we can do it without referencing, and then just basically create a string out of a character. But if we reference it, yeah, we basically need a way to create an array. Is sort of what we need. So that's something I'll need to think about. But I think this is something that I can commit. So let me do that. Let me actually move test.tasm and test.tim. And then I will do that again, get commit-tim. Added move stir instruction which can take a string at the top of the stack and push it. And it really is just duplicating it if you have just a string that you got from the string stack. Push it to the string stack. Also can take a character, enter, and push it as a null terminated string. Okay. Yep. Okay, so now I push that as well. So now, yeah, so let me actually look at arrays in assembly. Because I'm not sure in assembly x86, 64. Let me look at that, because I could sort of use that as inspiration, I suppose, as to how arrays would work in here. So, let's see. These are numbers that you want your array to contain. That's one. Okay. Yeah. Yeah, we should probably add like XOR and stuff like that as well. Not right now. So, index db0. Okay, so that is the index. Yeah. So I'm not exactly sure. Let's look at arrays in stack-based data. Let's see if there's something for that. Yep. So like an array really is just memory that is reserved, essentially. So we need some way to do that. Basically, let's see. So if we have yeah. So I'm thinking, right? We have this. So this doesn't actually exist anymore. Let me remake it though. And then open it back up. So we have, like I showed before, so we can push a string like that and get the string. Then it's on the stack. And we can push one and add to it. And then we get the last 3 elements. So let me put a new line here. And then write this. -1. And then compile this. And I messed this into push stir. There we go. And then run him, and there we go. So it does that. So we could push 2, and then it would just print 3. Push 3, and then it will just print the new line, like that. Or we could add 0 to it, and it would be the same. So we can index it, but I'm not sure how we would go about changing the index of it. So, because we can't really just like push a character and add that to it, because that would just add an index to it, because that's not what we want. We want to change the index of the array. So basically, so an array. So here is the start of the array where we're at. It's on the stack. So if we had an instruction, hello there, alright, so I pronounced your name the other day, Tanish Solanki. I'm very bad at pronouncing names, but hello, how are you doing? Yeah. Okay, so basically, if we had an instruction, which is like, index, let's see, index, and then perhaps a value, so like, something like that, and then basically, if we push the index that we want, and then it sets the index of whatever it is to whatever we tell it to, basically the pointer to it at least. But it needs to, yeah, needs to stay. So if we do a stir index, well actually, so if we have a pointer, then we could just try to do this, and we could go out of bounds, because it's not a safe language, but that's okay. So let's see. So if we have 0, we push 1, then that would change the first index, so 2 to BC, is basically what we would want it to do. So yeah, so we could add, sorry that I couldn't come yesterday because I was feeling very sleepy. It's all good. All good. Yeah. I understand. Yeah, so index. So we could add something like that, inst index. And as it expands and all that stuff, then we could adjust it to be more general purpose. But for now, it'll sort of just be for strings. So where would index go? perhaps it could go right here, inst index. I suppose that should work. And then let's see, that was right after in swap stir. So paste inst index and then break. Okay. And now in here we need to add it. So it is right here, inst index, and then lexer.h, and we can add inst index. Right, index, as well as in the lexer.c. Move stir. Yeah, so right here we want to add index. There we go, and that should be it. So let's build that actually, and let's add an assert false here, and then in test.tasm. Actually, it needs an operand, so I didn't consider that. Yeah, so let's actually add that. So that should just be in the parser. We need to check if it is, yeah, so it could be any, it's essentially the same as a push. So I suppose, yeah, suppose we could do this. Push, and then we expect int, yeah, so we could just expect character after it, but I suppose we can do this for now. So, and then type index. So let's make this 2 now. And then, yeah, we check the next one, and that should be all good. So, yeah, now let's go to tasm.c, and then when we encounter this, or head value.type equals type index, then it's the same thing. So, yeah, let's actually recompile that now, and then let's start tasm, and then it should be assert false. Okay, perfect. So, index, essentially, we're going to do an array. So can we do an array of like this? Equals top machine. Dot as function. Will that work? Perhaps. Word dot as, and then we want to do array machine instructions IP dot value. Actually, we want to pop off. So the pointer will be on the top. Actually, the index will be on the top. So int 64t index equals pop machine dot word dot as int. Okay, so let's do that. And yeah, so this actually will be index equals machine instructions IP dot value. So we actually don't know what the value would be though. We don't really have a way to get it either. So let's see what that does. It won't compile, so value use of void expression. Okay, so how can we make an, alright, well let's just do character right now. Char star, like that. And then we'll just do this dot as character. For right now. Okay, so this is not right. Alright, and then let's stop. Yes, that didn't work. How do you open terminal within NeoVim? Well, so I think, let me look. So this is the command actually. You do split, then term, :// bash. So that will just open a bash terminal. Yeah, so that's basically what it is. And then I just have a key value, which I can show you. /nvim. And let's see, it's in here, and then keys. Basically, I just have this, and so I forget why it's 12. I could make it something else, and then yeah, so it's not different yet. So let me see, yeah. So that just basically changes the height of it actually. So that's basically what it's for. That's how you do it. Yeah. So mine, it's just space t is the keybind, and that will open it. But yeah, you can also just do it typing split, and this will just split it 50-50. Term : / bash, and that will open it like that. Yeah, so that is how you do it. Yes. Okay, what was I doing here? So, we stack underflow, so get stir 0, push 1. So we don't want to, we do want to push one, because that'll get the first index. Push one, need one. So what actually, okay, let me write then. Okay, and then if I do that, index C, stack and flow. Okay, so that actually consumes everything and it doesn't push anything back. So we do need to push it back. So yeah, so we can actually then push pointer array, machine array, something like that. Yeah, if we pass this to a word pointer like that, and there we go. So now it should be on the stack. Yeah, so let me push 1 and then -1. And, okay, 1C3, so that did work. So we could change this index, and we could change this, and it has to be a character right now. I won't give you a warning if it's not. Actually, I just change it to the same thing, so we make it 0, like that. So now we can kind of index array, so this is a little bit more powerful, I suppose. Yeah, so there's probably a better way to go about doing that. So that is something I will need to think of, but for now, this does work, and it does open up some possibilities. So, yeah, so let's see. So what if we try to index out of bounds? Then, yeah, so it does actually, gets rid of the new one. And then if we go up one more, we can actually get rid of the null termination, and then we're going to get some problems. Or not. Alright, well now it just goes away, so yeah. That is sort of something, it's not unsafe language, so it's your problem. Your problem if you do that. And if it's -1, then it actually, yeah, it does weird stuff. So let me actually check for that. So in here, we can just do, if index is less than 0, then I install Gentoo Linux. Let's go, Gentoo! Hello there, how are you doing? Kazuya Web? I completely butchered that, I apologize. But yeah, Gentoo Linux. I only have Arch Linux, so I am just, I'm just a normie compared to you, I suppose. Print error, error index cannot be less than 0. And then that should work. Yeah, let me build that, and then if I try to run it, then it should say that. Alright, perfect. Yes, Gentoo Linux. That's an interesting distribution. Interesting distribution, that is for sure. Yeah, now this should work. Alright, perfect. So, we can index strings, at least. And it does some weird stuff if you don't have a string on the top of the stack. That's actually gonna stack underflow. But if we push, like that, then, yeah, segmentation fault. We can also, if we reference this, oops, if we reference it, actually that might not work. Maybe that. Let's see. Yeah, it can actually, we can change just a single character like that. Yeah. I use Arch on a VM. And then you have Windows as your main operating system, or is it a different one? Yes. Okay. Use it for the fact that I can get the best possible performance from the custom Zen kernel. Well, that is good. Getting good performance is good. How big of a difference does it really make, though? Like, genuine question. How big of a difference is it? From, like, if you just were to use Arch or something like that with the regular kernel? Yeah. What does it do? I've not messed around with Gentoo at all, so I don't really know that much about it. Windows, yeah. Windows is good. Not really, but yes, and that is, so what? Yeah, don't want to reference that. There we go. Okay, yeah, so that is pretty cool. I think that's something alone that could be pushed. Alright. Is your official operating system Linux, or do you have it in a VM? Yeah, it is installed bare metal Linux. I have, like, Windows installed in a virtual machine, but I never use it, so, yes, it is Linux. And, you just followed, so thank you, I do appreciate that. Yeah, so let me actually, remove test.dat, there we go, and git add added index instruction to index a string and replace the character. Essentially is what that is. So that instruction is gonna be changed around a lot. But for now, that is how it works. Yes. It is Arch Linux. Just to clarify, Arch Linux, vanilla Arch, install myself. Yes. Which to a Gentoo user, maybe that's not very impressive, but still. Yeah. Even though installing Arch is not really particularly difficult, if you know what you're doing at least. Yeah, okay, so we have the index instruction now. So what to do now? So you're like me, Windows is quickly gone from your PC. Yes. Completely gone. And it has been, so that was like about 2 years ago. I switched, like I had Linux installed in VMs before that or whatever, and then I went to Arch completely, and yeah, just has been ever since. And I've hardly used Windows at all. It's just for any Windows development. I probably use that. Speak French. Well, that is, I took French as a class, and I cannot speak it at all. So yeah. Yes. So bonjour, I suppose. Salut. Yeah, other words. I can't say with accent though, so I do apologize for that. Yes. Okay. So, what is by dot? That is that is probably a useful thing as well. I could free this though. No, we reallocate it, so it's fine. Where do we return this though? Where do I call this? Yeah, so output file. So then we could free, it'll just get freed by the operating system though. So don't need to worry about that necessarily. So now we can modify strings. It's all done by hand in Arch install, don't worry. I don't quite understand what you mean by that. Yes. X. You prefer JavaScript or TypeScript? Well, so I don't really use either, JavaScript or TypeScript, and I've never really used TypeScript. So, but I probably would prefer TypeScript now, but I don't really like either one, so, yeah. Yes, I like lower level languages, like C. Yes. But yeah, out of those two, I guess I would probably pick TypeScript, even though I've never used it. So yes, because, well, it just compiles to JavaScript anyway, so. But type checking, that's pretty useful. Pretty useful. Okay, so what am I doing now? So we have the index operation. So what is something that we could implement with that now? Some other test of sorts. Let's go into the test and make sure it all is working. Yep, so that works. Fib recursive. Perhaps I should modify the fib recursive so that it is not that slow. And I do know why it is that slow. So if I open it up, fib recursive. Basically, we're using recursion as well as loops. Because here, yeah, so basically we loop through each one, and we need to basically redo that. So the way it works here, we call fib and then call fib again and add. So can we not just print out the value here? So let me try that. So let me just protection Discord bot. So what does that do? You need to use TypeScript for that. Alright, yeah, let me do move fibrec. Whoops, I need to go into test. Move fibrec.tasm to fibrec-old.tasm. And then I will just modify this one. So let me just get rid of this. Okay, and then main 0. No, main. And then push 0. And then call fib. And then push it out and rect. So let me see what happens with that. Fibrec.tasm. Fibrec.tasm. And okay, so that didn't work. So let me go to fibrec-old and see. So what else do we need to do here? So call fib. So why does it actually segmentation fault? So what do we need here? Okay. So we have entry point main. That should be fine. Number of iterations. Perhaps this we need to do int to stir. There we go. Okay, so 0. Yeah, and then 1. So we can call it on each individual one. And then 2 is 1 as well. And then 3 is 2. Yeah, and then let's do something like 30 is going to be a big number. Yeah. Okay, so that is the answer. So then if you go down there, yeah, okay, so that is actually right. So that is how it is called, essentially. And we do have this int to stir, and we could probably use the standard library one that we implemented, but I'm not going to worry about that right now. So basically, we want to print each one as it goes through, because you can see, based on the time it takes, it's actually calculating all of that. So let me try dupe, and then push, in it out, and then right. Let me just see what that does. So then it's segmentation faults. So why does it do that? Because we need to int to stir again. Int to stir. That is, yeah, so let me not write here. Okay, and then that does a lot of stuff. So let me also do push new line and reference, and then push standard out, and then right, and then also pop. Okay, so yeah, that's not quite what we want. Yeah, let me start with a smaller number. Actually, so let's do 1, and let's see what it prints out. Actually, so that is right. It's just these first ones are all messed up. So, okay, 1 doesn't do anything, because it's less. So 2 should actually does 1, okay, and 3 is 2, and then 5, let's see. So 1 and 2, okay, so that is interesting. Interesting how that works. So, okay. So 9. And let me actually slash PASM fibrec old, and then run that. And we can see, yeah, you can see how slow it is. So 1, 2, 3, well, actually that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 34, and it does print 34, so, but it's not quite right. Because we skipped 21, and we print, you know, so it is, we need a different way to print that, I suppose. Yeah, let me look at actually, what is this? Fib recursive in a second. Let me look at that. NeoVim is better than VS Code. I agree with that, for sure. Not a big fan of VS Code. Alright, yeah, so this, actually, let me just look at in NASM x86 64 assembly. That is the one that I know the best. Alright, this is 32-bit, but, alright, push, move, sub, I just want to know how it's printed out, essentially, is what I want to do. Perhaps, instead of write, I could just do print, for testing purposes. So let me print like that. Okay. Actually, that is the wrong one. So, PASM, fibrec.PASM, fibrec.tim, there we go. Alright, so, yeah, so it prints it out like that. So, how can we get around that? So it prints it correctly. So why is it printing like that in the first place? So, yeah, I don't know. Yeah, so we actually want to print here as well. So, that actually, yes, we didn't duplicate it. So we want to do that. 14, 34, alright, so, still not right. We print more. And if it's 0 now, it'll work properly. 0 or 1 will be the correct number. Do you create virtual machine with the same utility as VMware and VirtualBox? Well, so all the virtual machines that I have on here, I actually use, Virt Manager, which uses, which uses QEMU. I think that is the right thing. I haven't used virtual machines in a bit, because I haven't had a need to, but this is what I use. I think that is, it's only for Linux though, so, why, I suppose that says that, yeah, actually, so it uses KVM or QEMU. Yeah. But on Windows, I used VirtualBox, yeah. Yeah. So this is, yeah. Yep. So that's what I use on here. I used to use VirtualBox though, and that is a good choice as well. VMware, not a big fan of that one. Yeah. It's not open source and all that stuff. So it is not ideal. Maybe I won't work on this right now. So, kind of boring. That's something I'll just do off screen. Let me bibrec old hasm. Bibrec there we go. Yeah, so I will just there we go. Okay, so hasm bibrec hasm and there we go. Okay, yeah. So that is, I'll just leave it like that for now. It's not a big deal. Let me just get clean now. So what is something more interesting to work on? Don't have a ton of time left, so let's see. So there's the open that still work actually. Whoops. Oh, I need to rebuild. There we go. Alright, let's try that again. Open.hasm. Open.vim. Enter the file name. Test.txt. Okay, and then that does work. So I think we could have a way where or basically reallocates the memory based on how much you type in. But I'm not sure how that would work exactly. So yeah. I would like to be able to do that though, because then you don't have to actually specify the length. And that would be pretty nice. Yeah, that did work. So let's look at open. There might be some ways we could update it now that we have some more instructions. So here we push, we not allocate the size, so it's just 4. It doesn't really matter. We just really need the pointer. And then we push 8, and then we standard in, and we read. So here, this could, let's see if that could be dynamically changing. So let me look in here. So it's native read. Maybe we could use one of the C standard library functions rather than using fread. So we get the length. Yeah. Let me actually see. See how to dynamically adjust fread. Is there a way to that? Like, I'm not sure. I'm not sure how it all works. Yes. Because that would be nice if you could just, based on how much they type, do that, and that would make it probably a bit better. So, okay, fread. So here, yeah, so they assign the buffer. Perhaps, yes, we just, let's see here, so this is the, yeah, actually that's the wrong one, that's right. So here we have the pointer, and this is what we allocate. And that's where we're actually reading to, writing to when we read it, essentially. So what if we, let's see, what if the length was just arbitrarily large? Maybe not. Buffer length is that. So, yeah, I don't know. What if we use the, is it, scanf? What if we use that and have an implementation for that? How is that implemented though? So it uses the read syscall, I assume. So, yeah, and that uses a format. So that's a little awkward to get the format, but I suppose we could do it without a format. Basically, yeah, so scanf, so we do that, and then we just need the but we're reading 2. So I think we could use that. Let's make a so scanf. So it'll be similar to this. Let me grab that, and it will be after all this. So before time, I suppose. So native read, and this will become scanf. I can type. There we go. So that's what we're gonna implement. So this will be scanf, and then we basically just want like that, and then buffer. So is the buffer what we want to? Yes, that's what we want to write to. So we pop that there. So that's the file stream. We don't need that. We don't need the length either. So we just need the buffer. So that is what we allocate essentially. Yeah, and then we write it there. And I guess we might not need to do that. And then we push the pointer. Yeah, so let me try that actually. So I need to implement it though. Down here in the natives. Yeah, so this is kind of how it's implemented. I can just implement it right here. So free, so I think that's the 6. 0, 1, 2. Yeah, so this will be the 7. Native scanf, there we go. And then that's implemented. So yeah, so now let me see. I don't think touch test.casm. Let me open that up. Test.casm. Alright, so we need to push where's 228 and then malloc. And then what to do? So then we have the buffer on the top. So then we can push. We don't need to push anything else, right? So we can just call the scanf, which is native 7. And then it will push it to the top. So let me just see if that works. Build it, and we do have an issue. So yeah, so the length equals size of buffer. No, equals sterling. Let's see, will that work? Perhaps not. I don't know. Let me see. Yeah, so actually I don't think it works because oh yeah, so we don't have malloc actually, so native 6. No. Is that what it is? No, which one is malloc? Let me look. Native devs. Malloc is 4. Okay, so native 4. There we go. Alright, so run that, and then whoops, test. Okay. So then let's just push 1 and then write. Which is actually native 1. Alright, so then it does output it, and it is, well, I think it's null terminated by default, right? So we don't even need this. We don't need to set this, I don't think. Link is unused. Yeah, so let me try that now. Yeah, so it's null terminated by default. So, perhaps we should add a new line, though. Is that a good idea? I don't know. Maybe not. The user can add that. Okay, so that's the new line. So we can't actually do that. So, yeah, I guess if we want a new line, then we could add one. But, alright. Code errors have a logic in C. How do you mean? Like, what is it that you mean by that? What is it that you mean? Code errors have a logic. I'm not sure how you mean. How you mean that? Yes. Okay, so we can do that. So this, let me add that to the standard defs. So it is like this. And it is 7. There we go, and okay, so push 28. So we can just allocate an arbitrary amount of space. So 1024. And then it's going to use a lot of memory, but that's okay. 1000. But yeah, then we can print out the whole thing. So that is quite nice. Then we can write to the file, and that's probably a better way of doing that than the fread that we were using. So yes, I am happy with that. So let me actually go ahead and push that. Let me remove test dot all that, and then add this, and then push. So added fread native function. or it's not fread, it is scanf. Right, so let me push that. Not a very big commit, and that is okay. So, all right, that looks like it worked. So now, let's see. That is not what I wanted to open. In here, let me move these to the header file actually, because I already moved the one in here, but I guess I didn't actually remove it. So let me just select all of this, right there, and then just paste it in there, and then I can get rid of it from here. Whoops. Yeah, that is fine. All right, so let me make sure it all still compiles. Okay. Looking good. So, yeah, that way we don't have to see them. Okay, so that is how they are used. This, that can stay. I'll leave it, because we have a native function for that. But we also have an implementation of it in the assembly. So, yeah, and it does work. It's not quite as good as this. I suppose we could use it with the string indexing, though. Yeah, if we created a string, and then we just index it in increment, we could do that. I'm not going to do that now, but that is something we could do. And then it could be pretty much exactly the same as this, where we end up with a string by the end of it. Yeah, that could be pretty cool. Right now the way it works, it just prints it out. Okay, here are the open modes, so we can use all of those. So let's see. Let me actually update the README. So this is outdated, so 29 instructions is not right. We have essentially 46. A lot of them aren't instructions though. So the count, I'm not going to count that, and the nope is an instruction. So we have 45. Yeah. So 45 instructions, as well as some native functions. This can be found in there. There's also working assembly. Yep. Okay. So that is, let me do quick start, and then basically batch, like that. So you want to do build.sh, and that should build it. You can build it for Windows as well. Actually, I should test the Windows and see if it all still works. But yeah, so we have build.sh, and then you can just run tasm assembly file.tasm, and then tire bytecode file.tin. There we go. So that is sort of how it's used. And then here is there's the example that I have. I could add quite a bit more to that, but yeah, just wanted to add the compilation instructions, because I think that is quite useful. Yeah, so now I'll test it on Windows actually and make sure it's all working. So let me build for Windows. Can we make a Raylib project on Linux? Yes, Raylib is on Linux. I'm pretty sure it has full cross-platform support. So yeah. Ooh, okay. So that is actually in the native assert function. Okay, actually, I think I don't want that. Yeah, so I don't need that. Let me get rid of that. So yeah. All right, build it for Windows again. In native time. So that doesn't work on Windows. Okay, that is interesting. Something I could do as well is Raylib, it works with C obviously. I could add a native function for the different Raylib functions and then actually use it from my assembly, and basically build a Raylib application in my programming language essentially. Yeah, I think that's pretty cool. So why does this not work? Cast a union from type not present in union. So that is a native time. So 118. So it doesn't like this. Okay, because this is word, and we'll just cast it to int64t. Alright, so let's try that. Alright, and then it looks like it works. Okay. So now let me try it, and I can just run it with wine for testing purposes. So let me have test. Okay, I just had test. Alright, so let me do admin.exe, and let's do fizzbuzz. And actually, alright, that does run it with wine. So on the third label. Ooh. Okay, that's not good. hang on. Let me... Yeah, so that is not good. Alright, but then it worked. Okay, so I'm not sure what that was. Oh, because now I'm using the native one. So one is dot. Alright, so it doesn't like the label. So that is something to do with the preprocessor, I assume? Or not the preprocessor, the label handler. Yeah. So I'm not sure why that would be. 48. Handle 3, but we do have handle 3 up here. So I will definitely need to look into that. But if I just compile it using the regular one, and then I use this to interpret it, then it does work properly. So we can compile it on Linux, just not on Windows, but we can run it on Windows from the one that's compiled on Linux. So that is a thing. Let me see, what other ones are broken? Let me try the fib recursive. Label main is already declared. Okay, so there seems to be a problem with the labels. Yeah, so main is it not like the entry point? Yeah, so I'm not sure where else it would be declared. If I get rid of that and just put jump main, does it work? No. Okay, so what if I don't put that at all? Then we'll compile. Label 0 is already good. Alright, so that doesn't work at all. So let me put this back. Entry point main. But if I compile it using the Linux one, so this is something that I will debug off screen, and then I do Pim, then it does all work. Okay, so that is good. It's not good that we can't compile it though. So I definitely will need to look into that. Excuse me. Okay, so let me try the int2stir one that I did. So the new one, which is not that one. So where do I have the? I implemented it somewhere. Print int, that's what it is actually. So let me try print int example. Okay, so it doesn't like that. Let me try just print int though. That is the header file. Alright, so yeah, it seems completely broken. And it was working before, so I'm not sure what that's about. But you can compile it with this example. And then and it does work. Okay, so that is quite interesting. But it seems that the runtime does work, so that is good at least. Let me status. Alright, so let me commit this. Updated readme, and then also let's see, there was one other also moved macros to header file. That's what I did. Okay. So let me make sure that works. 8 minutes ago. That is alright now, perfect. Okay, so clear this and get clean. Alright, so I am probably going to end soon. Because I do have to go. So yes, if anybody has some questions or wants to say something, then go ahead and chat and I will respond. Yes. Okay. Alright. I'll just make sure everything looks good. The README should have updated here, yep. Yes. So yeah, I think I'm gonna cap it at like 64 instructions. And try not to go over that. Just for no reason, like just kind of arbitrary. But I'm pretty sure with 64 we'd be able to do pretty much everything that we need to do. Okay, so it looks like nobody has any questions or anything like that. So probably going to end. Just one more quick overview of everything. Make sure all builds properly. Okay, that looks good. And then I'll clean it now. Let me look at the to-do list. So now next, I'll add a few more of these probably off camera. Actually, I need to fix the Windows compilation, or the Windows assembly of CASM. So that is not yeah, so I need to fix that. And I'll add some more of these. And then we'll work on these next stream. So I will just push that. There we go. Okay, yeah, so that is going to be the end, I suppose. So thank you for watching. Let me make sure that works actually.